we are going to sketch the velocity time graph that corresponds to this position time graph. And the way I do that is one line segment at a time. So I have a diagonal line here, which means the position is decreasing at a constant rate, which means the slope is negative, and the slope of a position time graph corresponds to the y value on a velocity time graph. So, and this will represent constant, negative velocity, right? So to find the slope, I do 2 points on the graph. I'll do these two. So I do y2 minus y1 over x2 minus x1. So let me write out my formula for that. This point right here, let's write out our x and y coordinates, will be, let's see, that's about 2.8, and the y coordinate 1.81 is both positive. This one, the x coordinate is 0, and the y coordinate 1.845, looks like 855, sorry. So my slope formula is y2 minus y1 over x2 minus x1, which is 0. And if you put that in the calculator, you get negative 0.01. That means on my velocity time graph, I will have a horizontal line. Here's my line tool, so I actually draw a straight line here. At 0.01 to the time which that occurred. Now the next time segment is a horizontal line, and the slope of a horizontal line is 0, which means the object has a velocity of 0. The other way we can say that is it's pausing. So there will be a transition. This really should be a gently curved transition there to a velocity of 0, like so. And then at 0, there will be a horizontal line across for that time segment. Next, we have a positively sloped diagonal line, which means a positive constant velocity. And if I do my point slope formula again, there's 0.2, 0.1. Let's see, y2 will be, looks like 1.87 minus y1, same y value as before, 1.81, divided by x2, which is 6, minus x1, which is 2.8, and that equals 0.03, positive 0.03. So on my graph, it's a constant slope, so a constant y value on my velocity time graph. And so I will have it's going to have to speed up because we can't have a vertical line on a velocity time graph, because that would mean infinite acceleration, which we know can't happen unless you're Superman. Up to 0.03, and then across, right about there. Then, up top, we have another horizontal line, which means pausing, which which means on the velocity time graph, we need to go back to the x-axis with a steeply sloped vertical line, but not a vertical line. Steeply sloped line, but not a vertical line. To the x-axis, where we will pause, meaning have a velocity of 0, until we get to the last time segment, which is again a negatively sloped diagonal line, very similar to this one, except with a different slope. So we have a constant negative velocity, and if we look at the 2 points, here's the point 2 and point 1, do our slope-intercept formula again, and let's see, y2 will be 1.84 minus y1, which is 1.87, divided by x2, which is 10, minus x1, which is 6, and that will give us a value of, looks like 0.015 approximately. So on my graph, I'm sorry, negative 0.015. On my graph, that will be, just to correct that math, that was actually 0.0075. I stuck that in the calculator just to check my math there. And that will take us below the x-axis to 0.0075. And again, another horizontal line. Right about there. So what we did for each of the segments is we took the slope, and with the slope, we figured out the y value for horizontal on the velocity time graph.